This is the OpenHPI course Linked Data Engineering, Lecture 1, Linked Data and the Web of Data. And in this last part of the first lecture, we want to talk about URIs, the Uniform Resource Identifiers, which are a basic building block of linked data because with a URI I identify and I reference things on the web. Okay, let me start with a simple question. What is this? An apple, you might say. But actually, this is not an apple. Some of you might know that this is simply the image of an apple. Why am I making this difference? This difference is important to understand how understanding really works. You might remember the Semiotic Triangle. There, the original apple, so the real-world apple, stands for the object of the real world. If I talk about the apple, I use a symbol. If you think about an apple, while hearing, for example, that simple apple, then you are dealing with a conceptual representation in your mind of that apple. So this is the concept. The point is, either the symbol or also the concept, both, they can act as a substitute for an object in the real world. And the point is, our mind is trained to use these substitutes as if they were the objects in the real world. And this is something really significant and important. So our mind is able to deal with symbols because it can relate these symbols to objects in the real world and act and think of them and do logical deductions like if the symbols were already the real object of the real world. So this is something quite important. So symbols and concepts, they substitute real-world objects. And to make use of it, to use symbols, of course, you have to know the name of the thing. So this is the so-called famous Rumpelstiltskin principle. Knowing someone's or something's true name will give you, or the person who knows the true name, power over them, which means then you can identify things, then you can reference things. This is the Rumpelstiltskin principle. And the URI on the web gives us the chance to apply this principle also for linked data, of course. And there you use the Uniform Resource Identifier to give everything its proper name. So the URI defines a simple and extensible schema, you know that, for a worldwide unique identification of abstract and physical resources. So you do not only, for example, reference web pages with the help of a URI, you also can identify and represent objects from the real world. Like, for example, you can represent books, locations, persons, relations among objects, abstract concepts, whatever you want. And URIs are already established in various domains. So most important overall on the web as a URL, but also, for example, for books and publications like these ISBN numbers or ISSN numbers, but also for other objects in the real world, you can use digital object identifiers which also conform to the URI schema. So the URI is quite a global uniform resource identifier that we will use on the web. Okay. So again, for the distinctions, what is a URL, what is a URI? The URL identifies usually what exists on the web. So it means web pages, web resources are usually identified and referenced via a URL. A URI, on the other side, is used to identify on the web what exists and what exists also in the real world. So for example, this here is an example for a URI that I can use to identify myself and to make assumptions and represent facts via RDF about myself. And how to form and use these URIs, you will learn now. So URIs are one of the building blocks. So they are centered here in the foundation of the semantic web layer cake. As you see here, we have already talked about this web platform as a foundation of linked data and the web of data and the semantic web. So URI are the important things. But how do I represent now a thing in the real world? Of course, I need some kind of substitute on the web for exactly this real-world resource. So this is the resource All of you know that. This is the Eiffel Tower. And I can, for example, identify the Eiffel Tower with the help of the URI of its website. So this will be www.toureiffel.fr. It's a French website, of course. And this URI identifies a resource on the web. On the web, this resource usually is represented by some kind of available metadata. So this metadata that you have here represented in the website stands for the resource in the real world. But you have to distinguish. Of course, this is not the resource in the real world itself. It's only data about the resource. If you access this metadata, for example, with your browser, this metadata, which is given in HTML, defines a so-called presentation of this metadata content. So the presentation of the website in the browser. So this gives you information about the resource in the real world. And if you look at linguistics, for example, there are certain notions that you usually use to distinguish between the resource in the real world and information about the real source. So in the web, it would be between the website and the resource in the real world. The resource in the real world is the so-called designatum, and the website which holds information about the resource is the so-called designator. So the designator describes the designatum. So this is from linguistics. And the Eiffel Tower is described or designated by its web page, by the content of its web page. And therefore you distinguish between the resource and information about the resource. This is important. Okay, so you can use URIs that already exist on the web, for example, like for the Eiffel Tower. But for yourself, maybe there is no URI, so you have to come up with one. How to do that? How to define a URI by yourself? So the first thing, of course, you should somehow avoid overlaps. So use as a namespace for your own URI, possibly your own website as a namespace. And then, of course, what you should do is, on the same place, provide information, of course, about the resource, about yourself, about this thing you are representing with the URI. And HTTP and the web platform provides a very nice feature that can be used to access different kind of information about the same resource. And this is the HTTP content negotiation. Some of you might already be familiar with that. With the help of content negotiation, I can access different information or different kind of information about the same resource dependent on which kind of content I want to see, what I have negotiated with the help of HTTP. So the point is we use separate URIs for the resource, the designatum, and its documentation, the designator, but they can be referenced via a unique URI which then is translated in one of these separate URIs with the help of HTTP content negotiation. I will show you how this will work. Another variant would be to use two separate URI references which reference the same URI, and the other one, so the designatum, for example, is only a fragment of this object. So you do this with the help of a fragment identifier. We will also have an example on that one. Okay, so let's have a look. Content negotiation works the following way. We have here, for example, the representation of the Eiffel Tower in DBpedia. We have already learned about DBpedia as this huge semantic database that is made or created from the content of Wikipedia. So if I want to get information about the Eiffel Tower in a human-readable form, I use content negotiation, and I can use a unique identifier for the Eiffel Tower, which is what you see here, http dbpedia.org/resource/Eiffel Tower. And I do content negotiation, which means I state in my HTTP message which kind of information I want to have. And I want to have text information which is encoded in HTML. So I send together with the HTTP GET request that I want to have an accept header text HTML. Okay, This is sent to the web server, and the web server then switches to the representation of HTML of this Eiffel Tower. And this has another URI, so this is point 2 here. So this then switches to dbpedia.org/page/Eiffel Tower, and then this is displayed, or this is an HTML document which will be displayed at the user. So which means we identify the resource, we say we want to have human readable information about that, and then we get back exactly that one, which is then the HTML page of the Eiffel Tower. Let's see if this is linked. It's linked, so I click on it. And you see it translates. So resource here translate into page, which means then I have here human readable information. You can see this again. I can, for example, here write resource. But of course, the browser assumes also text HTML, so I send this away and this is translated to page. So it's exactly this content negotiation mechanism which returns in the end this information about the Eiffel Tower in human readable form. Okay, next trial, let's see the machine readable information about the Eiffel Tower. So then what I have to do in content negotiation is I simply have to provide another information in the accept header, which means I send my HTTP GET request and then say I want to have, as a result, RDF and in XML serialization. I access exactly the same URI as before. I have a different accept header, and then what the web server does in the process of content negotiation, this then, or this URI will be mapped on another URI, which then is dbpedia.org/data/Eiffel Tower, and this then is the result in RDF XML representation, which then is returned to the original sender, so to the client, and then there will be as a result the RDF document and not the HTML document. So this is content negotiation with linked data resources. So to subsume this, we can of course try it out. You can try it out also at home with yourself, with your own computer. So what you need a program like, for example, CURL or curl, which does nothing else but provide you an, which provide you an HTTP request to a web server, and we will try this out. So for this I have prepared a command which you can use to test this at home, and you can make content negotiation with a CCurl or curl program. I copy now this curl command and put it into a terminal window here. So I copy it here. You see here curl, and I want to have a web page. It's this web page, dbpedia.org resource Eiffel Tower, and I send with it the accept header text HTML. And you see here the return document. Definitely, as you see here, you have HTML markup. This is definitely an HTML command. If I want to have an RDF document instead, I simply have to change the accept header. Be careful with that. I have here to write application RDF plus XML. So this is a MIME type. You can look up the different MIME types, and of course every single endpoint or reference point here in the web of data has different or various varieties on how you can do this content negotiation and what kind of formats will be passed back to you. So let's try that one. And you see here, this now, you don't know it by now, this is an XML serialization of exactly this information about the Eiffel Tower. So it's a lot of information as you see here, but this is clearly XML. So it's a markup language with own tags, and many of these tags are based here on the RDF namespace. Okay, so try this at home. Let's get back to our presentation. So this is content negotiation. Content negotiation is really an important important process in the web of data, because you are able to access different kind of information about a resource. You can get machine-readable information, and you can get human-readable information about a resource with exactly the same URI. You only have to distinguish the way of access, what kind of access header you are using. Okay, and the access then, of course, this content negotiation is based on HTTP with URI. We have seen this now. Another way to distinguish between designator and designatum, for example, is to use so-called fragment identifiers. Probably you have seen already fragment identifiers. So usually you have an entire resource, which is here Harald_fov.rdf. So this is the designator. This is a file with information about me in the so-called FOV format, or with FOV vocabulary. This is an RDF vocabulary which is able to represent network information, personal information, and it forms a so-called social network. And in that resource, of course, I have to talk about me, myself. And a very simple thing is then, in this resource, I can use the same URI. I talk about me, myself, with the help of something like that, with this hash identifier. The interesting thing then is, if I use this one and want to dereference this fragment identifier, simply because of the usual way how HTTP works between web server and client, the entire file here, the entire RDF file, will be returned. You cannot simply return me, which is a part of this RDF file. This is the standard way how web server react. They give back to the client the entire file, and then usually the client takes care of simply returning the specified point within or given by this fragment identifier. But here usually the entire file, which means then the designator, is returned. But if I want to make an assumption about me as a resource and not by the information about me, then I can use exactly this fragment identifier. Let's have a look on how this really works. So you can access this file, my FOV file, and we can have a look in this FOV file. I have it here in a text editor. As you see here, it's also RDF, and RDF here is encoded and serialized in XML. So this is an XML format, and you see here, for example, my name is Harald Sack, for example, my given name, my family name, and there is more information. So there is some nickname information about me available, some information about homepage and depictions and stuff like that. And all this, of course, is done with the help also of this fragment identifier, because here I say this is a personal profile document, and the this document is made by me. So usually this is a relative URI then, which means this fragment, this hash me, is appended to the original URI, which then denotes exactly me as a resource. And here you see RDF ID me. Here is information then about me, about myself. Okay, so this is the second way how this distinction between designator and designatum can be made on the web, in the web of data, with the help of either content negotiation or with the help of fragment identifier. And now we are able to denote and reference and identify resources on the web, while on the other hand, in the same time, provide information about these resources with exactly the same URI. With this, we have already covered the first two linked data principles. First was use URIs as names for things, and use HTTP URIs so that people can look up those names and get interesting information about it. And this can be then made possible with the help of HTTP content negotiation. And with this, simply if we change the representation format from HTML to RDF, we have here then the basic building block or basic architecture of the web of data. So we have changed the traditional web architecture to the architecture of the web of data with its building blocks URI, HTTP and RDF, as you see here. Okay, and of course, this ends the first lecture, and in the next lecture we will take care about RDF and we will learn more about how RDF really works, what kind of serializations for RDF are possible, and of course we will also learn about the schema language to make models of RDF and to form own and new vocabularies.